this module, we will examine the incorporation of building services and the specific requirements and best design practices to ensure ongoing fire and acoustic performance of the overall building. In this presentation, we will cover the types of building surfaces typically found in mid-rise buildings, the important layout considerations that should be considered during the building's design process, the specific NCC requirements around fire and sound, the importance of incorporating service shafts and service runs and how these might be constructed, and finally the requirements around service and pipe penetrations in fire-protected elements and the placement and use of access panels. Typical building services that need to be considered include electrical services such as power and lighting, plumbing services, both hot and cold water supply and drainage, as well as gas supply, heating, ventilation and air conditioning, or HVAC as it is generally termed, and also more commonly today, IT services such as telecommunications, internet and the like. There is also the need to consider the use of plant rooms, service shafts for ventilation, pipes, garbage, etc., and also service voids, plenums and false walls and ceilings. To achieve the optimum outcome, it is critical that the design and layout consideration for services be undertaken early in the design process. The preliminary selection of building services and service locations should be closely considered when determining the general building layout. Careful thought needs to be given to the issues of safe future maintenance, modification and addition of services without compromising fire safety and sound separation. A key design approach that needs to be stressed is that the number of service penetrations through fire-protected timber construction should be minimised as far as practicable. Typical matters for consideration in the design phase include the following: what service penetrations can be grouped together, what provisions need to be made for maintenance and additional future services, where can service shafts be located to minimise nuisance noise and facilitate fire compartmentation. And in residential buildings, will each SOU be serviced by self-contained heating and air conditioning systems, or will centralised systems be provided? Another key matter for consideration is how service penetrations can be minimised through fire barriers to ensure the integrity of the fire-protected timber elements are maintained. In this regard, if we look at a single sole occupancy unit surrounded by adjacent sole occupancy units, as shown here, we will note that the SOU is effectively a self-contained fire compartment, the internal automatic sprinklers and fire-grade plasterboard providing the fire protection. The fundamental design principle here, whenever possible, should be to maintain the integrity of this fire encapsulation around this fire compartment. With the design and installation of services, the aim should be to not breach the fire-rated linings, but instead to investigate other approaches to incorporate services. These include the use of false ceilings, the use of false walls when needed, or better still, for electrical wiring and power points, the use of skirting ducts. Also the use of false walls to allow the installation of baths, and the running of plumbing within the SOU's floor void, above the fire and sound rated ceiling. The following slides discuss these options in more detail. The use of false ceilings is a highly recommended approach. This allows the fire and sound rated plasterboard systems to be installed directly to the supporting floor structure. The false ceiling is then fitted below this, allowing a range of surfaces such as downlights, fans or sprinklers to be easily run without breaching the fire rated linings. This configuration also allows owners to alter or move services if needs be in the future without compromising the fire safety of the building. Maintaining the integrity of fire rated walls is also critical. Using false walls or concealed voids again means fire-resisting elements do not have to be penetrated and allows for easy future reconfiguration. Battening out walls in wet areas is also a recommended approach. In wet area construction, fire-rated walls can be compromised where bath and shower base units need to be recessed into the wall. A good approach here is to batten out the wall using 35mm battens and insulation if necessary, after the fire-resisting linings have been applied, and then providing additional water-resistant linings over the top. The bath can then be installed into the batten space without affecting the fire and sound-rated wall. An alternative approach for electrical wiring and power outlets is the use of skirting cable and service ducts. A range of new architecturally aesthetic products is now available as illustrated here. Services can be fitted behind cable ducts without penetrating fire-protected timber elements, and again readily configured in the future if necessary. With office-type buildings, they typically tend to be open-plan layouts, utilising one or more cores, usually lift and stair shafts. In these types of buildings, facilities such as toilets, kitchens and vertical service shafts are generally consolidated around these cores. Power communications and air conditioning systems can also be distributed quite easily, As with open plan layouts, there is very little fire compartmentation required. Residential buildings, such as apartments and hotels on the other hand, differ dramatically from offices in that each sole occupancy unit is a fire compartment in themselves, and they also contain bathrooms and kitchens. In these types of buildings, it is much more practical to use vertical service shafts distributed around the floor for services such as drains, waste and vent pipes. NCC Specification C1.1, Fire Resisting Construction, Section 2.7, Enclosure of Shafts, requires that shafts must be enclosed at the top and the bottom with a floor or ceiling system of the same FRL and RISF as the walls, except where the top of the shaft is extended beyond the roof or the bottom of the shaft is laid on the ground. The specific NCC fire requirements for fire-protected service shafts in mid-rise timber buildings are as follows. For Class 2 and 3 buildings, load-bearing elements must have an FRL of 90-90-90 and non-load-bearing elements -90-90. For mid-rise office buildings of 4 stories and above, Type A construction, the FRL required is 120-90-90 for load-bearing elements and -90-90 for non-load-bearing elements. For all classes, the RISF and MRISF values remain the same at 45 and 30 minutes respectively. In terms of the acoustic requirements for the service shafts, the NCC states that if a shaft, duct, soil, waste or water supply pipe serves or passes through more than one dwelling, the duct or pipe must be separated from the rooms of the dwellings by construction with an RW plus CTR not less than 40 if it is adjacent to living areas in a dwelling, or 25 if it is adjacent to a kitchen or bathroom. This is also required where a duct or pipe is located within a wall or ceiling cavity. If timber framing is used to construct service shafts, then these are required to be sheeted with fire-grade linings on both sides of the shaft. This is very difficult to construct in practice. Accordingly, laminated fire-grade plasterboard products are often used for shafts. These laminated shafts can be easily built from one side, after the general wall fire-rated linings have been installed. These shafts need to be constructed as per the linings manufacturer's recommendations. Some key points to remember though include the acoustic performance needs to be adequately addressed and the cavities must be closed off between floor levels. It is possible to overlook this, which then provides a means for fire spreading around the building. There are also specific interface details for joining the laminated shafts to walls and floors to maintain the fire performance, as illustrated in the details shown here. Service plant rooms also have quite specific NCC requirements. Clauses C2.12, separation of equipment, and C2.13, electricity supply system, generally require certain types of equipment to be fire separated from the remainder of the building, by construction having an FRL of 120-120-120. For Class 2 and 3 buildings, designed to the NCC DTS provisions, this means that some service plant areas may require to be enclosed in construction having an FRL of 120-120-120, rather than the FRL of 90-90-90, which generally applies to the rest of the structure. Accordingly, it is often the most practical solution to locate the plant rooms in the basement or ground floor, where a reinforced concrete structure is often used, which can be modified locally to achieve the required FRL by adjusting the reinforcement cover if necessary. Service runs are also a really important concept. The best option in mid-rise timber buildings using fire-protected elements is to plan the layout of required services and potential future services carefully, utilising service risers, service shafts and ducts, and additional false linings to conceal services, minimising penetrations through fire-protected timber elements as far as practicable. It cannot be stressed more strongly that wherever possible and practical, avoid using the cavities within the fire-protected timber elements for services. In apartment buildings, service risers are often located in common lobbies around building core lift and stair shafts, and from this point, services are then run horizontally to individual apartments, as shown in the illustration here. This provides for easier common access for inspection, maintenance, or reconfiguration of services if needed. And if designed correctly, the shaft housing can be non-fire rated compartments. This can be seen in this illustration of a lift lobby or corridor and an adjoining apartment or sole occupancy unit. It can be noted that the wall and floor elements are constructed of fire-protected timber, shown here as the brown elements, with pink borders representing the fire-rated lining. Some other non-fire-rated construction can also be seen, the grey walls and the grey false ceiling lining. Now, adding typical runs of building services, such as water, electrical and data. Using this method means that services can be run easily in horizontal service runs above false ceilings, but fitted below the fire-protected timber ceiling system without penetrating fire-rated linings. Or similarly, services can be consolidated and run in vertical service risers. Looking at a vertical service riser where it penetrates the fire-protected floor ceiling system. It must be noted that the opening at each floor level needs to be formed such that no timber is exposed, the fire-rated plasterboard covering all horizontal and vertical faces as seen here. This then means that the FRL and RISF requirements are not compromised and services can be run through the opening. The actual opening can then be protected using a fire barrier pillow, mineral fibre bat or other proprietary fire protection system. This approach allows the opening to be altered and then readily reinstated if any additional services need to be run. A similar approach is used where a horizontal run of services needs to pass through a fire-protected timber wall system, as seen here. Again, at the bottom of the opening, all faces need to be covered with fire-rated plasterboard, such that no timber is exposed. At the top of the opening, the fire-rated ceiling system continues through. The actual opening again can then be protected using a fire barrier pillow, mineral fibre bat or other proprietary fire protection system. It should also be noted, with this configuration, that the access panel to the left of the wall can be a simple non-fire rated panel, as it is located in the false ceiling lining. There are a range of different options that can be used for closing off penetrations in fire-protected openings. The Mid-Rise Timber Buildings Technical Design Guide provides details on these, and also reference to the appropriate regulatory information reports that provide evidence of suitability referred to, as shown here in the green border of the technical manual. As discussed in the previous slides, the preferred option for running services is in false ceilings and wall voids, and in specific service risers and runs. Using the actual cavities within fire-protected timber construction to run cables and pipes presents a number of problems, including difficulty in maintaining the RISF or MRISF ratings of the elements at points of service penetrations, risk of fire protection systems not being installed properly after modifications or additions to existing installations, and risk of disruption of concealed cavity barriers during modifications or additions. If there are no other options but to run surfaces in or through the cavities, there are some solutions provided in the Mid-Rise Timber Buildings Technical Design Guide. In this slide, you can see the requirements for housing a general purpose outlet or GPO in a fire-rated wall, and the specific plasterboard lining configurations that need to be used inside the wall cavity. The details shown here must be followed to ensure appropriate protection is achieved. For metal pipe and cable penetrations through fire-protected timber members, where this cannot be avoided, existing proprietary protection systems that have achieved the required FRL in plasterboard systems can be used, in conjunction with internal plasterboard linings or mineral fibre insulation packing, as shown opposite, to satisfy an RISF of 45 minutes or an MRISF of 30 minutes, as appropriate. For plastic pipe penetrations, the following details have been developed to maintain an RISF of 45 minutes or an MRISF of 30 minutes. Again, the details shown here must be followed to ensure appropriate protection is achieved. There are also options for proprietary plastic pipe penetration protection systems with integral insulation to protect the penetration. Manufacturers of these products will need to be able to provide appropriate test evidence to demonstrate compliance for these proprietary products, and products should be installed as per the manufacturer's specification. In terms of access panels, these may be utilised, but constructed as shown in the diagrams presented here. If proprietary access panels are used, then these must meet the required FRL. Where practicable, shafts, service risers and service ducts should be readily accessible from public parts of the building to facilitate maintenance and inspection. But access hatches, panels or doors providing access should normally be secured to prevent unauthorised access. In summary, careful thought and provision during the preliminary building design process needs to be allowed for initial optimal services placement and also the future safe maintenance, modification and addition of services without compromising fire safety and sound separation. The number of service penetrations through fire-protected timber construction should be minimised, as far as practicable. Whenever possible, use false ceilings and wall facings, service runs, risers and ducts, allowing services to run behind the non-fire rated face without penetrating the fire-resisting elements. If a service void cannot be utilised, then any services in fire-protected walls or floor ceiling system cavities must be carefully detailed to ensure adequate performance. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.